I'm Elisa, and we're back. We are looking at the lymphatic and immune systems, and this time we're going to go through the structures. So, one of the most important roles that the lymphatic system has is that it operates in fluid recovery. Humans need a lot of fluid. We actually lose a lot of fluid because we looked earlier in AMP1 at the skin and how we have massive amounts of, especially water loss, right? And that's part of our human biology is endurance runners, and a handful of other things. So the lymphatic system is supposed to kind of constantly be engaged, especially in this fluid recovery. Um, Sometimes it doesn't always work, but when it does, this fluid is constantly being filtered out of the blood capillaries. Remember, there's that, let me draw it, right colors, okay. Some veins, right? And there's a venule. And then here's some like capillaries for the arteries and the arterial, right? So blood is kind of constantly being pushed into this area and then pushed back out through the veins. However, like not all of that fluid really makes it back out. Some of it pools in the tissue a little bit, or some of it's actually intentionally meant to stay out there to hydrate or to allow for the cells to pick up any of the nutrients that they might need or dissolve any of the waste that they might need to back into that plasma that's kind of left over. And that plasma that's left over that just sits around in the tissue, we call it the lymph, right? It's a little bit of the bilge water of the body. It's like the bilge. That says blige. Does that bilge? I don't know. I've never worked on a ship. Water of the tissues. Okay, and so it's meant to be kind of gross essentially, but mainly what happens is the blood capillaries are going to be reabsorbing about 85%, but then the rest of it still needs to be picked up. And so this is between 2 to 4 liters left over of that plasma-ish water every day. And so that's going to pick up that more viscous lymphatic or that lymph, right? And we're going to eventually return that back into the blood to the veins. Remember, we're not ever returning that to the capillary or up to the arteries. So because we have these kind of like areas where plasma and waste in the body are able to pool, we also get, like high concentrations of proteins or leftovers, waste products. And a lot of that is food for things like microbes that might be in the system still. Right, by no means is the internal part of the body or the blood ever really truly sterile, right? Ideally, it's more sterile than a lot of, places, but it isn't. So if we have invaders, oftentimes they're going to kind of hang out here. This might be a place for them to like start growing or multiplying. Other things that we also find in this area are also like maybe cancer cells, right, can like harbor in these areas and begin to grow. And so we've been learning that this is also one of the places the immune system might find these types of cancer cells and be able to begin to present immunity against them. Anyway, so this extra fluid is going to be, hosting these foreign cells, or, and sometimes like cancer cells or just, other body cells. And these chemicals, generally waste products from the tissue, it's going to pass through these like centers, and we call these centers nodes, right? They're nodes. So like if here's like the lymphatic system, right, and it's branching together and it's working its way back up to the veins, every once in a while you'll find these like little kind of rigid nodes, right? And these little rigid encapsulated nodes um, are where immune cells are generally going to hang out, and they're going to kind of like go through and take a look at who's actually there. They're going to kind of review to see like, who's who's floating around in the body and the tissues, right? And so they're going to kind of scan through all of that. And sometimes that's a really important training ground, obviously, for them. Should they find that there's some like, bad guy invaders, they're going to activate a protective immune response at this point. There's also, like I said, like a training center. A lot of these white blood cells actually end up going to kind of like a white blood cell college, if you will. Other parts that are pretty important about the lymphatic system is the ability to absorb certain fats, lipids. Okay, so lacteals in the small intestine are going to absorb dietary lipids that you are eating, right? And so they're not always absorbed by the blood capillaries. They need that like longer wait time, right? That the lymphatic system can provide. The lymphatic system is made of lymph, which we talked about as being that recovered fluid. The lymphatic vessels, which are kind of like veins in a way, that are going to be the transport system or the tubule system of the lymph. The lymphatic tissues are going to be composed of lymphocytes, right, which is the white blood cells of the body. Specifically types that are include macrophages, which are like the larger ones that are going to be eating these smaller cells like bacteria cells or cancer cells or all that. And they're going to go on and protect and populate in the rest of the body. The lymphatic organs, of which there are a couple, defense cells, especially concentrated in these organs, thinks thymus, for example, especially in the earlier years. And so they're separated from surrounding organs by like this really kind of hard encapsulation, right? They're really like wrapped up tight in what we call these and there are connective tissue-based capsules. So lymph itself is a clear, colorless fluid. It's similar to plasma, but it's got a lot more in it, including like waste and dissolved like CO2 and all this other stuff, but a lot of the protein as well, maybe less protein. It originates as extracellular fluid, right? It has been put there by the venous system from the capillaries draining into it, about 15% left over by the capillary exchange. So this fluid is drawn into what we call the lymphatic capillaries, and it's going to be different depending on where you find it. So the lymph that's in the intestines is going to be a little bit different than what you find in the lymph nodes in different parts of the body. So before I really get into the vessels, I think that's a pretty good place to stop. So I hope that was super helpful, and I hope you're having a great day. Bye.